It's time to learn about the scientific principles that we see in our everyday lives. Today's topic is lasers. Take a moment to think about the Jefferson Memorial in Washington, D.C., the Queen Victoria Market in Melbourne, Sydney's Harbour Bridge, and Egypt's 3,500-year-old obelisk. What do all of these things have in common? The answer is that they all had built-up grime that was removed using lasers. All of these structures are examples of how laser-based cleaning technologies can be applied to buildings and other structures. Since the mid-1980s in Europe, laser restoration technology has been very popular and has been used on the exterior walls of historic buildings, old statues, and even historical paintings. That's not all. Lasers are used in various places in our everyday lives, including medicine, industry, and the military. Laser stands for light amplification by stimulated emission of radiation. The word literally tells us the basic principle of how lasers work. In general, when atoms are struck by light energy, the electrons that move around outside of the atom move faster and away from the center of the atom. This is similar to what happens if you tie a stone to the end of a rubber band and spin it harder and harder, causing the rubber band to stretch and the stone to move further and further away from your hand. As electrons move away from the center of the atom, their velocity decreases and they return to their original positions. They emit this lost energy as light, equal to the amount that their speed was reduced. This phenomenon is called the spontaneous emission. This also is the process through which the light that we see is produced. When a light photon passes by an electron, which is relatively far away from the center of the atom, that electron emits as many light photons as passed by it and slows down to return to its original position. This is called the stimulated emission. Lasers produce very bright light in one direction as the result of stimulated emission. Lasers have several characteristics. First, they are monochromatic, which means that all of the light they emit is the same color. Second, they demonstrate coherence, which means that the phase of the wavelength of the light they produce is exactly the same both spatially and temporally. Third, the light they emit travels only in one direction. This is called directionality. Lastly, they are also characterized by high brightness. Currently, the Apache Observatory in New Mexico is measuring the distance between the Earth and the Moon by measuring the round-trip time of lasers fired at the reflectors left on the Moon by Apollo 11 and 15. Lasers can be classified in several ways. First, depending on whether they emit light continuously or through repeated cycles of emission and non-emission, lasers can be divided into continuous wave lasers and pulsed lasers. Depending on how long light is emitted during a single pulse, pulsed lasers can further be classified as nanosecond lasers, picosecond lasers, femtosecond lasers, and attosecond lasers. In addition, depending on the materials they use, lasers can be classified as solid-state lasers, diode semiconductor lasers, gas lasers, and fiber lasers. Laser technology has limitless potential applications. By analyzing the spectrum of plasma generated when a laser is irradiated to a material, it is possible to find out the components of that material. Lasers can also be used in quantum computing to produce rapidly flickering electrical signals. In addition, lasers can be used in optical forceps that can grab and manipulate DNA and RNA. When we enter the space age, laser technology using the properties of light, which is less affected by gravity, is expected to be of great importance. The Korea Institute of Machinery and Materials Department of Laser and Electron Beam Technologies, established in 1989, has been studying laser technologies for many years. They have been developing various laser technologies, such as a tailored blanked welding process in which automobile frames are welded using lasers, and on-the-fly technology that enables laser processing over large areas, a mirror-like surface cutting technology that can cut glass cleanly using lasers, a glass welding technology that can weld pieces of glass together, a laser cleaning technology that can remove rust, paint, and impurities from the surfaces of objects, and a battery welding technology using lasers. Korea Institute of Machinery and Materials has also transferred many of these technologies to companies. In addition, the Korea Institute of Machinery and Materials research team has recently begun developing laser light sources based on their experience developing laser processes and equipment. The Korea Institute of Machinery and Materials Department of Laser and Electron Beam Technologies is producing cutting-edge laser technologies to become the world's leading producer of laser technology.